This video is on transformations of graphs, and we're just going to look at the horizontal and vertical transformations. Different parts of a function's equation affect the properties of its graph. If we understand what part of the function controls a particular feature, then we can learn how to transform the function. We're only going to look at translations. So the first one is if we have an equation y equals a function and we add a k value to the end of it. This will create a vertical translation of k units. What that means is if our k is greater than 0, the graph will be moved upwards on the x-axis. It'll be translated upwards. If our k is less than 0, then the graph will move downwards. It will be translated downwards. Next one, we have y equals f and then in brackets x minus h. So this time we're just adding or subtracting to the h. This creates a horizontal translation, which means the graph will move left or right h units. Now the main thing to note here is that in this equation, you will notice that the general form here has x minus h. It is a minus. So for the part here when we said if h is greater than 0, the graph moves to the right. So this would look like the x minus h in the bracket, because if we're subbing in a positive value of say 2 for h, this would look like x minus 2. And then if our h is less than 0, the graph will move to the left. That would look like an x plus h, because if we put in, say, negative 2 into that equation, we'd have x minus 2, which creates a positive. So you just have to be mindful of that. So if our h value is greater than 0, which means in the bracket is actually a minus, the graph will translate to the right. And if it's less than 0, which means our h value in the bracket would be a positive, then it moves to the left. Then the last one, if we had y equals f and then in brackets the x minus h plus k, we actually just combine the first two we just talked about. So it's a translation of the original function of h units horizontally and k units vertically. Let's have a look at example. Consider we've got the function fx equals 3 minus x and we want to graph the original. And then what would y equals the function with x minus 2 in the brackets, and part B, our original function, and the y equals a function minus 4. On these graphs, I've already graphed the original equation, so those are the lines of 3 minus x, which I've already graphed. Right now, we just want to graph the translated function. Now, in here, we have x minus 2. Now, remember, this would be in the form x minus h, which therefore means our h equals 2. That means that we are translating our original function 2 units to the right. Because if we look back up here, if our h is greater than 0, it moves to the right. So we just look at a few points on the graph and we just move them 2 units to the right. So I've got a few dots on here, so 2 units to the right means that one will go to here, and then 2 units to the right. This one will go to there. The x-axis will go to here. So I've just picked a few points on the line and just moved those 2 units to the right, and now I can draw my new line. And that is our translated graph of the original. Now part B, we have the original function, and this time we want the function with the minus 4 after the whole function. So it means our k would equal minus 4, which means it will move minus 4 units downwards. I'll just add some points here. And this time I want to go 4 units down. That's 1, 2, 3. So from when the y-axis was 5, now the y-axis would be 1. And do that for a few points, just so you have a few points there to be able to draw the line. And there is that function translated as well. Example 2, this time we just want to find the equation of the resulting function g of x when f of x equals minus x squared plus 3 and it is translated. So the first we want to translate the 3 units to the left. So move to the left, our h value is going to be less than 0, which means our h would equal negative 3. Because we want 3 units to the left, so the h will be negative 3. Now our original function is f of x equals negative x squared plus 3, and we know when we do a horizontal translation, this is what has to happen to the x. We have to minus h from the x. So to create our new function, which will be g of x, we will go negative. Now, when we do this, we put it in brackets. So we'll have the bracket of x minus, because that's the general form, and then we put in our value, which is to make 3 units to the left, which is -3, all squared, and then we still have the +3 on the end. So that horizontal translation, we just alter the x. All right, so we have to put the x in brackets and plus or minus from there. And then we can simplify this and we'll have negative x plus 3 all squared plus 3. Now for part B, 2 units upwards and 3 units to the right. So for 3 units to the right, our h has to be greater than 0, which means our h will equal 3. And then we want 2 units upwards. For upwards, our k is going to be greater than 0 as well, which means our k will equal 2. Now let's start with our original function here. So we'll have f of x minus h plus k. It's kind of the general translation form. Now let's put in everything we have here. So let's start with our horizontal translation. So the same with the last one. We're going to put x in brackets, and the minus is a general form, and we're going to put in 3 and square that. We still have a +3 at the end of the equation, so that stays, but now we also need to apply the k, which is +2, so we're going to add another 2 to the end, and then we can simplify this. So we'll have minus x minus 3 in the brackets, all squared, and then 3 plus 2 is 5. And so that is now this function with those two translations applied of 2 units upwards and 3 units to the right. And that is the end of this video.